Google Cloud Storage, often called GCS, is generally well regarded among its users. It's known for being reliable, scalable, and performing well. Let's look at some of the experiences people have shared. Regarding reliability, many users find GCS to be very stable. Some have said they've never had any major outages or lost any data. Others use GCS for important backups and have been impressed with how long it stays up and how durable it is. Scalability is another area where GCS shines. Users say it easily adjusts to their growing storage needs. They've been able to store and get back large sets of data without any problems with performance. GCS lets people store and process huge amounts of data efficiently, which is essential for big data applications. Performance is also a key strength of GCS. Users report that it delivers fast and consistent performance, even when lots of people are using it at the same time. Some use it for delivering content and have seen significant improvements in how quickly their pages load. GCS optimizes performance based on how data is being accessed, which has helped some users reduce delays and improve how quickly their applications respond overall. Cost-effectiveness is another benefit of GCS. It offers a cost-effective storage solution, especially for large sets of data. Its different storage options let users optimize costs based on how they use the storage. The pricing model of GCS is transparent and predictable, which helps users budget and manage their storage costs effectively. Google provides excellent support for GCS. Users have received timely and helpful responses from their technical team. The GCS documentation and online resources are comprehensive and well maintained. However, there are some issues that users have reported with GCS. Some users have reported occasional billing errors. GCS does not offer direct file-level management, which can be a limitation for some use cases. Some users have experienced latency issues when accessing data from specific geographical regions. Overall, GCS remains a popular and reliable cloud storage solution for many businesses. Its scalability, performance, and cost-effectiveness make it a strong choice for both large and small organizations. To understand Google Cloud Storage more deeply, let's delve into some of its technical aspects and how it achieves its reported benefits. GCS is designed with a distributed architecture. This means that data is not stored on a single machine, but rather spread across multiple servers in different locations. This distribution is a key factor in its reliability and scalability. If one server fails, the data is still accessible from other servers. This redundancy helps ensure high availability and data durability. The scalability of GCS is achieved through its ability to dynamically allocate resources as needed. As the amount of data stored in GCS grows, the system can automatically add more storage capacity and processing power. This means that users don't have to worry about manually managing storage capacity or experiencing performance bottlenecks as the data grows. GCS offers different storage classes to optimize cost and performance. These storage classes include Standard, Nearline, Coldline, and Archive. Standard storage is designed for frequently accessed data and offers the highest performance. Nearline storage is designed for data that is accessed less frequently, such as monthly backups. Coldline storage is designed for infrequently accessed data, such as archival data. Archive storage is designed for data that is rarely accessed and offers the lowest storage cost. The choice of storage class depends on the frequency with which the data is accessed and the performance requirements of the application. The performance of GCS is optimized through a variety of techniques. These include data caching, load balancing, and data compression. Data caching involves storing frequently accessed data in memory to reduce latency. Load balancing distributes traffic across multiple servers to prevent any single server from becoming overloaded. Data compression reduces the amount of storage space required and improves data transfer speeds. GCS also offers a variety of features to help users manage their data. These include object versioning, access control, and data encryption. Object versioning allows users to keep track of changes to their data over time. Access control allows users to control who has access to their data. Data encryption protects data from unauthorized access. The billing model for GCS is based on usage. Users are charged for the amount of storage they use, the amount of data they transfer, and the number of operations they perform. The cost of storage varies depending on the storage class. The cost of data transfer varies depending on the source and destination of the data. The cost of operations varies depending on the type of operation. Google provides a variety of tools to help users monitor their GCS usage and manage their costs. These tools include the Google Cloud Console, the Google Cloud Storage API, and the Google Cloud Billing API. GCS is integrated with other Google Cloud services such as Compute Engine, Dataflow, and BigQuery. This integration allows users to easily build and deploy applications that use GCS for storage and data processing. For example, a user could use Compute Engine to run a virtual machine that stores its data in GCS. They could then use Dataflow to process the data in GCS and BigQuery to analyze the results. GCS is also used by many third-party applications and services. These applications and services use GCS to store and manage data. For example, a content delivery network, or CDN, might use GCS to store its content. A backup service might use GCS to store backups of user data. GCS is a versatile and powerful cloud storage service that can be used for a variety of purposes. Its reliability, scalability, performance, and cost-effectiveness make it the strong choice for both large and small organizations. When considering Google Cloud Storage, it is important to also understand some of the limitations and potential drawbacks. While the service is generally reliable, scalable, and performant, there are situations where it might not be the ideal solution. As some users have noted, occasional billing discrepancies can occur. It is crucial to carefully monitor your usage and billing statements to identify and address any errors promptly. While Google provides tools for monitoring usage, proactively reviewing bills is still recommended to ensure accuracy. The lack of direct file-level management can be a limitation for certain use cases. Unlike traditional file systems where you have granular control over individual files, GCS primarily operates at the object level. This means that managing individual files within a bucket can be less straightforward. If your application requires frequent manipulation of individual files, you might need to consider alternative storage solutions or implement additional tools to manage file-level operations. Latency issues in specific geographical regions can also be a concern. While GCS has a global infrastructure, data access latency can vary depending on the location of your users and the region where your data is stored. If your application requires low latency access from specific regions, you should carefully consider the location of your GCS bucket and potentially explore using a content delivery network, or CDN, to cache data closer to your users. Security is a paramount concern when using any cloud storage service. While GCS provides various security features, such as access control and data encryption, it is your responsibility to configure and manage these features effectively. You should carefully review the security best practices for GCS and implement appropriate security measures to protect your data from unauthorized access. Data transfer costs can also be a significant factor, especially for applications that involve large amounts of data being transferred in and out of GCS. While GCS offers competitive pricing, data transfer costs can add up quickly if you are not careful. You should optimize your data transfer patterns and consider using data compression techniques to reduce the amount of data being transferred. Vendor lock-in is another potential concern. Once you have stored your data in GCS, it can be difficult and costly to migrate it to another cloud storage service. You should carefully consider the potential for vendor lock-in before committing to GCS and explore options for data portability. Understanding the Service Level Agreement, or SLA, is also important. The SLA specifies the guaranteed uptime and performance of GCS. You should carefully review the SLA to ensure that it meets your requirements. If your application requires higher levels of availability or performance, you might need to consider using additional features, such as multi-regional storage. Monitoring and logging are crucial for maintaining the health and performance of your GCS deployment. You should implement robust monitoring and logging solutions to track key metrics such as storage usage, data transfer rates, and error rates. This will help you identify and address any issues promptly. Compliance requirements can also impact your use of GCS. If your application is subject to specific compliance regulations such as HIPAA or PCI DSS, you should ensure that your GCS deployment meets those requirements. Google provides resources to help you understand and comply with various regulations. Disaster recovery planning is essential for protecting your data from unexpected events. You should develop a comprehensive disaster recovery plan that includes regular backups of your data and a strategy for restoring your data in the event of a disaster. Google offers various features to support disaster recovery, such as cross-regional replication. Finally, staying up to date with the latest features and best practices for GCS is crucial. Google is constantly adding new features and improving the performance of GCS. You should regularly review the Google Cloud documentation and attend Google Cloud events to stay informed. By carefully considering these limitations and potential drawbacks, you can make an informed decision about whether GCS is the right cloud storage solution for your needs. Remember to weigh the benefits of reliability, scalability, performance, and cost-effectiveness against the potential challenges and implement appropriate measures to mitigate any risks. Using Google Cloud Storage involves several key steps. Firstly, you'll need a Google Cloud account. If you don't already have one, you can sign up for a free trial. Once you have an account, you can access the Google Cloud Console, which is the web-based interface for managing your Google Cloud resources. The next step is to create a project. A project is a container for all of your Google Cloud resources, including your GCS buckets. You can create multiple projects to organize your resources. After creating a project, you can create a GCS bucket. A bucket is a container for your data. You can create multiple buckets to organize your data. When creating a bucket, you'll need to choose a name, a location, and a storage class. The bucket name must be globally unique. The location determines the geographical region where your data will be stored. The storage class determines the cost and performance characteristics of your data. Once you have created a bucket, you can upload data to it. You can upload data using the Google Cloud Console, the Google Cloud Storage API, or the GCTool command line tool. The Google Cloud Storage API is a programmatic interface for accessing GCS. The GCTool command line tool is a command line interface for managing GCS. After uploading data to a bucket, you can access it. You can access data using the Google Cloud Console, the Google Cloud Storage API, or the GCTool command line tool. You can also grant access to your data to other users or applications. Access control is managed through Identity and Access Management, or IAM. IAM allows you to define who has access to your data and what they can do with it. In addition to storing and accessing data, you can also perform various operations on your data. These operations include copying data, moving data, deleting data, and renaming data. You can also use GCS to host static websites. To host a static website, you'll need to create a bucket, upload your website files to the bucket, and configure the bucket for static website hosting. GCS also supports object versioning. Object versioning allows you to keep track of changes to your data over time. When object versioning is enabled, GCS automatically creates a new version of an object whenever it is modified or deleted. You can then access previous versions of the object. GCS also supports data encryption. Data encryption protects your data from unauthorized access. When data encryption is enabled, GCS automatically encrypts your data before it is stored. You can also choose to use your own encryption keys. GCS is a powerful and versatile cloud storage service. It can be used for a wide variety of purposes, including storing data, hosting static websites, and backing up data. By following these key steps, you can start using GCS to store and manage your data in the cloud. It's worth noting some additional considerations when working with Google Cloud Storage. One such consideration is data consistency. GCS offers strong consistency for most operations, meaning that once you write data to GCS, you can immediately read that data and see the changes. However, there are some cases where GCS provides eventual consistency. Eventual consistency means that it may take some time for changes to propagate to all replicas of your data. This can happen, for example, when you are accessing data from a different region than where it is stored. In most cases, eventual consistency is not an issue. However, it is something to be aware of, especially if your application requires strong consistency. Another consideration is data durability. GCS is designed to be highly durable, meaning that your data is protected from loss or corruption. Google guarantees 99.999,999,999% annual durability for GCS objects. This means that you are extremely unlikely to lose any data stored in GCS. To achieve this level of durability, GCS stores multiple replicas of your data in different locations. This ensures that your data is still available even if one or more of the replicas are lost or corrupted. Another consideration is data security. GCS provides a variety of security features to protect your data from unauthorized access. These features include access control lists, or ACLs, identity and access management, or EAM, and data encryption. ACL allow you to control who has access to your data at the object level. IAM allows you to control who has access to your data at the project level. Data encryption protects your data from unauthorized access. GCS also supports customer-supplied encryption keys, or CSEK. CSEK allows you to use your own encryption keys to encrypt your data. This gives you even more control over the security of your data. Another consideration is data compliance. GCS is compliant with a variety of industry standards, including HIPAA, PCI DSS, and SOC2. This means that you can use GCS to store sensitive data that is subject to these regulations. Google provides a variety of resources to help you understand and comply with these regulations. Another consideration is data lifecycle management. GCS provides features for managing the lifecycle of your data. These features allow you to automatically transition data between different storage classes such as standard, nearline, cold line, and archive. This can help you optimize your storage costs by storing data in the most cost-effective storage class for its access patterns. You can also use lifecycle management to automatically delete data after a certain period of time. This can help you comply with data retention policies. Understanding the differences between storage classes is crucial for cost optimization. Standard storage is ideal for frequently accessed data that requires low latency. Nearline storage is suitable for data that is accessed less frequently, such as monthly backups. Cold line storage is designed for infrequently accessed data that can tolerate high latency, such as archival data. Archive storage is the most cost-effective option for data that is rarely accessed and has the highest latency requirements, such as long-term archives. By carefully choosing the appropriate storage class for your data, you can significantly reduce your storage costs. Versioning is another important feature to consider. When enabled, versioning allows you to keep multiple versions of your objects in GCS. This can be useful for recovering from accidental deletions or modifications. You can also use versioning to track changes to your objects over time. However, it's important to note that versioning can increase your storage costs as you will be storing multiple copies of your objects. So use versioning judiciously. Object metadata is another aspect to be aware of. Each object in GCS has associated metadata which provides information about the object, such as its content type, creation date, and size. You can also add custom metadata to your objects. Metadata can be used to store additional information about your objects, such as tags or descriptions. This can be useful for organizing and searching your objects. Access control is crucial for securing your data in GCS. You should carefully configure access control to ensure that only authorized users and applications have access to your data. You can use IAM roles and permissions to grant access to your data. You can also use ACL to grant access to individual objects. Monitoring your GCS usage is essential for understanding your storage costs and identifying potential issues. Google Cloud Monitoring provides a variety of metrics that you can use to monitor your GCS usage, such as storage usage, data transfer rates, and error rates. You can also set up alerts to notify you when certain metrics exceed predefined thresholds. By monitoring your GCS usage, you can proactively identify and address any issues before they impact your applications. Data replication is another important consideration for ensuring data availability and durability. GCS automatically replicates your data across multiple regions to protect it from regional outages. You can also choose to replicate your data across multiple continents for even greater protection. Data transfer costs can be a significant factor when working with GCS. You should carefully consider your data transfer patterns and optimize them to minimize your data transfer costs. You can use data compression to reduce the amount of data being transferred. You can also use Cloud CDN to cache your data closer to your users, which can reduce data transfer costs and improve performance. Security best practices should always be followed when using GCS. Enable encryption to protect your data at rest and in transit. Use strong passwords and multi-factor authentication to protect your Google Cloud accounts. Regularly review your IAM roles and permissions to ensure that only authorized users have access to your data. Stay up to date on the latest security vulnerabilities and apply any necessary patches or updates. By following these security best practices, you can help protect your data from unauthorized access. Finally, remember to consult the official Google Cloud documentation for the most up-to-date information and best practices for using GCS. The documentation provides comprehensive information on all aspects of GCS, including features, pricing, and security. By leveraging the documentation, you can ensure that you are using GCS effectively and efficiently.